looking at trapezoids today. So who can remind me of the definition of a trapezoid?
A trapezoid is something that has one set of congruent base angles.
You're getting to isosceles. We're not quite there yet. Hannah?
A quad with at least one pair of parallel sides.
So it has to have at least one pair of parallel sides. That's our definition of a trapezoid. Okay, it's a quadrilateral with just at least one pair of parallel sides. The reason we say at least one pair is because if it was just one pair, then we would break our hierarchy. I couldn't go to a parallelogram where I get the second pair. Okay, so we say at least one pair so that we still have that hierarchy. We don't break that apart. All right, just like we had a feature of the kites that we had to talk about with those ends, we have another one with trapezoids that we need to talk about. And it's going to be what we call the bases. Okay, the base or the bases of a trapezoid are the sides that are parallel. Okay, so it's my parallel sides. Based on this picture here, what are my bases? What sides are they? Megan?
A, D, and B, C.
Are A, D, and B, C parallel to each other?
No, let me
No,
get it again.
try again. There you go.
A, B, and D, C.
A, B, and D, C. Okay, those two there are my bases. The reason we have to talk about bases is because we have different features that apply to bases and base angles versus the other angles. So we have to know which sides are our bases so that we can talk about what angles we're working with and whatnot. What is our definition of isosceles trapezoid? Yes, Asa.
The definition of a trapezoid plus the base angles are congruent.
So we have a trapezoid and then our base angles are also congruent. The reason we say the base angles are also congruent is so that we can look at the opposite sides as being congruent as well. That's actually where we're going to actually define this today. We're going to look more at those two non-base sides are congruent. Okay, so the two sides that are not my bases are also congruent. What are those two sides on this one? Abby, what two sides are my congruent sides here?
AD and CB.
AD and CB. Now technically I didn't tell you this one was isosceles. Okay, so we wouldn't technically be able to say that. This picture probably is. So it is those sides. But I should be giving you a picture like this where I actually have them labeled. Okay, so I should be giving you something there where I actually tell you those sides are congruent. Alright, now we have to talk about some parallel line stuff. Okay, we spent a couple of lessons back a while ago talking about parallel lines. All of that's going to come back real quick here. So, with parallel lines, what parallel lines do I have in this picture here? Asa?
A, B, and D, C.
A, B, and D, C. So those two lines are parallel. I'm going to look at the angles A and D. To do that, I'm going to look at my two parallel lines plus that other line, AD. Once I have that, I can say that these are parallel up here and down there. So I have a set of parallel lines cut by what we call a transversal. Okay, when we have that, this is where we start to get alternate interior angles and exterior angles, all of that kind of stuff. We're going to use that to talk about angles A and D. So if I look at angles A and D, what would I know about them? Asa?
They're supplementary.
They're supplementary. How do you know they're supplementary?
Because the line AD is flat, so the angles made, since one's obtuse, the angles made by that line are plus the angles of A. It's a smaller one, and you can't take away an angle, so it has to be 180.
I get what you're saying. It doesn't quite mathematically fit what we're trying to do, though. Skylar, do you have a reasoning why they would be supplementary?
Because they're alternate. No, are they alternate interior?
They're not alternate interior angles.
But it's like I remember the lesson where we had two pair of lines and one intersecting line,
Mm-hmm.
and then we find the angles of
Yep.
those.
And so what we really need to do here is I need to find another angle that's next to the one I'm trying to find. So if I look at this angle up here at the top, I'm going to call it angle 2. Okay? How do angle 2 and angle A relate?
They're the same.
They're the same. Why are they the same? They're corresponding angles. Now I have two angles right next to each other that form a straight line. What are those called?
Supplementary.
They're supplementary. They have another name though.
Line.
Two angles that are forming a line. They're a linear pair. Okay, so these two here are a linear pair. So that tells me that A and D are going to be supplementary. We're going to go through a proof of that here in a minute, but let's add.
Hey, Miss Brown.
Hello. All right, so here is your angle theorem at the bottom here. Okay, so in a trapezoid, consecutive angles between our parallel lines are supplementary. So they have to be next to each other, and they have to be between my two parallel lines. All right.
Change it.
So the other thing we talked about yesterday as far as a kite and a rhombus was symmetry. We also want to talk about that here in a trapezoid as well. Okay, so if you look at your next slide, I'll flip to it in just a second. You will see that I have two trapezoids there. Okay, one is just a regular trapezoid, one is isosceles. Okay, the first one, let's look at the one on the left. Is that a trapezoid or an isosceles trapezoid?
Trapezoid.
That one's the one that's just a trapezoid. Does that one have a line of symmetry?
No.
No, it does not. So our regular trapezoids don't have any symmetry to them. But if I look at an isosceles trapezoid, do I have any lines of symmetry?
Yes.
Where is it?
Down the
Right
middle.
smack dab down the middle.
Right smack dab down the middle.
It's
Okay.
not a perfect line.
That's not a perfect line. It's close as I can get.
Isn't there a feature where you can draw a straight line?
There probably is, but it's going to take too long to get there. Okay? But gives us the idea. So I have that line going straight down. That is going to be my line of symmetry in an isosceles triangle. Okay, so let's actually talk about that. In an isosceles triangle, that line that goes through there is going to be our perpendicular bisector of both bases.
I'm writing this down.
You are. If it's not on there, you might already have it.
Wait, so
You don't have the top piece, it doesn't look like. So you're writing down in an isosceles triangle, if I have the perpendicular bisector of one base, so say the bottom one here, I bisect that, then it's also the perpendicular bisector of that top base.
did you like start over with recording or no?
No, it's still going.
Whatever's-
Okay, so if I bisect both, they're both perpendicular bisectors, and that is my line of symmetry. So that tells me about my sides, but I can also look at some angles now. So if I have that line of symmetry, what do I know about angle A and angle B?
They're equal.
They're the same. Why are they the same?
Reflection.
Because it's a reflection. If I'm looking at symmetry, I'm dealing with reflections, and what do we know is preserved by reflections?
Angle measure.
Angle measures. So those are my corresponding angles from my reflection, which tells me that they are congruent. What other pair would that apply to?
C and D.
C and D. What do you think we call those pairs of angles?
Pairs.
Not linear pairs, because they're just congruent, they don't add up to be 180. We've used the term already. What is the side A, B, and CD? What are those sides called?
Bases,
They're my bases, so what should I call those angles?
base angles.
Base angles.
You gotta
Okay.
put the extra line from C and D, otherwise you're saying all those angles are equal.
Happy? I didn't put them up here, so I should put 2 down here, right? There.
We could just draw another.
So those are our base angles, and that's what we were talking about when we first defined an isosceles trapezoid, was that those base angles are congruent. Because then I have that line of symmetry, I have my congruent sides, all of that still works out. Hannah?
On the picture.
Yeah.
Do the bottom, like, the bottom lines where you have the lines for it, should that be 3 or can it still be 1?
I guess it should be 3, because they used 1 on the side here. So it should be,
Just switch the one on the side to 3.
you could do that, yeah. Okay, so basically now we have 3 pairs of congruent sides that we could work with. Alright. Let's go ahead and go to the next slide here. Oh, sorry, here's my picture, nice and filled in. And we get those congruent pieces and those congruent sides. Last one down there at the bottom, the angles at the base are congruent. We already talked about that. I forgot that that shows up on the bottom. Okay, so angles that share a base and an isosceles trapezoid are congruent. So again, that's that angle A and B, and then C and D. All right, let's look at the next slide. What do we see?
Proofs.
It's a proof.
Wait, no.
All right, copy it from somebody else. All right, so for a proof, what goes on the first line?
The given.
We're doing them again. They're coming back. Okay, we're not going to see as many as we did with triangles, but they're going to come back a little
Are they
bit.
gonna be on
Okay.
their test?
I haven't looked at your test. I'm not sure if there's one on there or not.
Mr. Brown,
Okay,
my grade will go from an A to an E.
it's okay.
Sick.
All right, so we're starting with the given that ABCD here is a trapezoid, and I have parallel sides of AB and CD, and I have AD has been extended to the point E. That just gives me an extra angle on the outside there that I'm working with.
How are we supposed to fit that in that tiny box?
I just drew an arrow.
You could just draw an arrow, that's fine. So you're gonna take our given and pull it down, put it in there, okay? I'm gonna pop up, okay? So it's a trapezoid. The big part there is that AB is parallel to CD, because that's gonna give me what my bases are, so I can work with those. What is my justification for that first line?
Given.
It's always just a given, and that's the information I am told. Alright, so what we are trying to prove here is that angle 1 and angle D are supplementary. This goes back to when we first started this lesson. We looked at those consecutive angles are congruent. We're gonna actually prove that that's always going to be true. Okay? And so we kind of already went through this a little bit, but we're gonna go through it a little more formally here. So I have that the measure of angle 1 plus the measure of angle 2 is equal to 180. That's my angle up top here, angle 1 and angle 2. Why are those two equal to 180? Yeah, Asa?
They're supplementary.
They are supplementary. What makes them supplementary though? What kind of angles are they, Hannah? They're a linear pair. They form that line. Okay? That tells me that it has to add up to be 180 because they're forming a straight line. Okay? So my justification there is that I have a linear pair. Alright, now for the line 2, you don't have anything.
Yeah, we do.
You do have something?
Yeah, corresponding angles.
Oh, well, you have corresponding angles. All right, I don't have that. So that's going to be our justification. So what goes into the conclusions for line 2? What are my corresponding angles that I want to work with?
A, E, and D.
It's going to be angle 2 and angle D. Okay? Because I have my parallel lines here that were A, B, and C, D, I have parallel lines, so I can talk about corresponding angles. And I want to look at the ones that are in the same position, which was angle D and angle 2. I heard someone say angle E. Angle E is not really an angle, it's just a point out there. So we can use the number that's labeled there instead. Okay? I use 2 and D are congruent, and again, that's because I have corresponding angles.
You just start the recording again?
Every time I click forward, it resets the time. Alright, line 3 there, I have angle 1 plus angle D is equal to 180. What is my justification there?
Supplementary angles.
Not quite supplementary.
Linear.
They are supplementary. That's what I'm gonna get to down here. But I have angle 1 and angle D is equal to 180. Megan?
Is it CPCF?
It's not CPCF. I need triangles for CPCF.
Oh.
Anna? It's not a linear pair.
What?
Naya? It is substitution. And going back to substitution. Because in line 1, I have that angle 1 and angle 2 are equal to 180. Now I know that angle 2 and angle D are equal to each other, so I can swap angle 2 for angle D. That gives me the new statement I have there in line 3.
Why can you?
Okay.
Here's why
So
can
I've done
you-
that swap. That's just a substitution. So my last justification there that I need to fill in is a substitution.
Why
Okay.
can't you use CPCF for anything other than a triangle?
Actually, I guess you could. You just have to have that they're congruent. So I need actually 2 figures. I don't have 2 here. I'm just looking at 1. So you can do it with more than triangles. We just need 2 of them, which we don't have here. All right. What goes in the last line there?
Angle 1 and angle D are.
What I'm trying to prove. So angle 1 and angle D are supplementary.
We could have solved it earlier, just put the proof down there when we're done.
You could have put the proof down there, but that's not the order my slides went, so. Alright, last thing we want to look at is 2 examples of actually finding some angles and side lengths based on what I give you. So, here is a trapezoid. Okay, notice I didn't say it's isosceles, it's just a trapezoid. And I have that angles, or AB is parallel to CD, so I have my bases there. And I have angle C, right here, is 118. I want to know all of the other angles, okay, or as many as I can find. I will tell you you can find all of the angles. Okay, so I'm looking to find the measure of angle A, angle B, and angle D. Which one's going to be the easiest to find there?
C,
We already have C.
B.
Probably D. Okay, what do we know about angle D? It's going to be the same. Those are those base angles. So by that symmetry and that reflection, those are going to be the same.
But you didn't say they're isosceles.
Oh, you are right. But they are still.
We confused our teacher.
Did. I'm wondering if we can say that or not.
You could find angle B.
Just say the
We can find angle B. We all agree we can find angle B, right?
Yeah.
Okay, what's angle B going to be?
62.
180 minus 18 or 60, 118, which is 62. I don't think you can find angle A or angle D.
You can say
Oh,
they're.
come on, I
You can
believe
say they're
you.
isosceles.
Unless you say that it's isosceles, but we didn't say that, and I can't assume that. So I don't think we can find A and D, unless somebody has another way to do it, but.
Well, guess what? I
a
found it
protractor.
because it said the picture shows me it is not isosceles.
The reason, so the reason that unless I know this other side or an angle over here, I could move that side around and keep the same length, and I could make it 2 90-degree angles. Right? I know those 2 angles have to add up to be 180, but I don't know what either of them are, so there's no way to know which one's gonna be bigger or smaller. We could go based on the picture, but again, we can't assume things from the picture. Okay?
There's
So
gotta
that
be
is my
something
bad.
higher
We can
math
only
that
find
allows
those 2.
us to find that. Isn't
You could start to do some stuff with, you have a parallel line, you could throw in another line to have a transversal, but it's gonna get super complicated and even that might not work for you. Okay? Alright. Let's look at our last one here. This one is isosceles. This one we will be able to find all of our angles. Okay? So I have an isosceles trapezoid with the bases G, H, and JK. What do I know about G, H, and JK then? If they are my bases, they are parallel, okay? There's a couple ways I can tell you what lines are parallel or what lines are bases. This is kind of the other way to do that. I can either say they're parallel or that I give you the bases. Okay, so these sides here and here are parallel, and I have that HJ is 31.8, and my angle at H is 19. So that angle there is 19 degrees. Let's look at sides first. If I know that the side HJ is 31.8, are there any other sides I could find? Sydney? I could find GK. And what would GK be equal to? 31.8. So that one is the same because that's my isosceles sides. So those are the sides that match up. Okay, those non-bases are going to be congruent. So those sides there are also congruent. Now let's look at angles. I told you we will be able to find all of our angles here. So I have angle H, so we're trying to find G, I, and J. Okay, which one's the easiest one to find?
There's an I. G.
Oh, it's not an I. That's okay. Sorry. That's okay. Okay, so I have angle G, angle K, and angle J. Which one's the easier one to find? G. What do we know about angle G?
It's 19.
It's the same, so it's going to be 19 degrees. Now we need to find either J or K. Okay, how could I find either one of those? Hannah?
180 minus 19.
I could do the 180 minus 19 because either one of those is going to be supplementary to the one next to it. So J is supplementary with H, K is supplementary with G, so they have to add up to be 180. So I could do 180 minus 19, which gives me 161. Okay, so both angles here are 161. Okay, so I found all of my angles and two of my sides. Are there any other sides or angles I could find? I have all my angles, so there's no more angles I could find. But could I find anything about my two sides, JK and GH, as far as their length?
No.
There's not. And there's nothing I can do there. Eventually, when we get to trigonometry, you could. Actually, even then, that's rough to do. Okay? But you could, eventually. We're just not going to get there yet.
Wait, what?
Okay? Finding the sides of JK and GH.
Okay, if I knew the side of JK, I know the side of GH.
No, they're not the same line.
Even then, you would have to be using some trig.
Maybe I think.
Yes.
Maybe.
All right, so that is going to be it for today. Your homework is on page 332. It is numbers 3, 5, 8, 11, 14, 15, and 17.
That's not
Okay.
a lot.
Not a whole lot, just kind of scattered around. They probably have multiple parts, that sort of a thing. Okay, so you got some time here in class to get working on that.